When you're just starting out in AWS, connecting things is pretty easy. But what happens when you start to grow? Suddenly, you're faced with a really critical question. What's the best way to build the network backbone that connects all your virtual private clouds, your VPCs? Well, today, we're going to break down the two big solutions, the classic VPC peering versus the more modern Transit Gateway.
So, let's frame the problem here. You start with a couple of VPCs, then maybe a dozen. Then suddenly you've got 50 or more. They might be in different accounts. They might need to connect to your own on-prem data centers. How do you get them all talking to each other efficiently, securely, and in a way that doesn't become a total operational nightmare to manage? 4,950. Now, that's not just some random number I pulled out of a hat. Nope, that is the exact number of individual peering connections you would need to build and manage if you had just 100 VPCs that all needed to talk to each other. That single number perfectly captures the scaling challenge we're about to tackle. So here's our game plan for today. First, we're going to dig right into that connection challenge. Then, we'll put our two contenders, VPC Peering and Transit Gateway, under the microscope. After that, we'll do a direct head-to-head comparison and then wrap it all up with some clear guidance to help you choose the right solution for you. Sound good? Let's get into it. Look, the real heart of the problem here isn't connecting just 2 or 3 VPCs. I mean, anyone can do that. The real challenge pops up as your architecture gets bigger. Each new VPC you add makes the management overhead grow exponentially. We're talking about updating dozens, maybe hundreds, of route tables for one tiny change. Your network gets fragile and becomes just a complete nightmare to troubleshoot. All right, let's kick things off with the OG solution, VPC peering. For years, this was the go-to method, and for some pretty good reasons. It's a direct point-to-point way to link up your virtual networks. You know, at its core, VPC peering is actually really simple. It creates a private, direct link between two VPCs. The best way to think about it is like building a private road directly between two houses. It lets traffic flow back and forth freely and securely, almost like they're part of the same big property. Okay, this right here, this is probably the most important thing to understand about VPC peering. It's this concept of non-transitive routing. It's a technical term, but the idea is simple. Let's say you peer VPC A with VPC B, and you peer VPC B with VPC C. Well, that does not mean A can talk to C. There's no pass-through traffic. For A and C to communicate, you have to build another totally separate peering connection. And that is how you end up with that tangled, complex mesh we talked about. So you see the trade-off, right? For just a few VPCs, peering is great. It's easy to set up, it's cheap, you only pay for the data you send. But the moment you start to scale, that non-transitive thing means your network diagram starts to look like a giant spider's web, and it becomes incredibly hard to manage. Plus, you have a hard cap of 125 peers for any single VPC. Okay, so to solve this massive scaling headache we just talked about, AWS came out with Transit Gateway. And this isn't just a small upgrade. We're talking about a completely different way of thinking about your network, one that's designed from the get-go for complexity and scale. So instead of building, 1,000 little private roads, Transit Gateway is more like a central airport hub. Every VPC, every on-prem network just connects once to the hub. And from there, the Transit Gateway acts like a super scalable cloud router. It's the air traffic controller, basically, directing everything where it needs to go. And this image, wow, it just lays it out perfectly, doesn't it? You can see the Transit Gateway right in the middle, and these spokes reaching out to all the different VPCs, a VPN connection, even an AWS Direct Connect for a private line to your physical data centers. All that complexity is just gone. Management is central. You can see how clean this is compared to that spider web we were talking about. This is exactly what the AWS well-architected framework recommends, a clean hub-and-spoke design. And the magic that makes this whole thing work is transitive routing, the complete opposite of what peering does. You connect everything to the gateway just one time, and from there, it can get to any other network that's also connected. It's this simple principle that lets you scale up to thousands of connections while keeping everything under central control. Okay, but of course, all this power and simplicity comes at a price. There are trade-offs. With Transit Gateway, you're paying an hourly fee for every single connection, plus you pay for every gigabyte of data it processes. So it's definitely more expensive than peering. And because your traffic has to go through that central hub instead of going direct, it adds a little extra hop to the journey. That can mean a tiny bit more latency than a direct peer. All right, we've met our two contenders. Now it's time for the main event, a direct head-to-head comparison.
This is where we're going to put everything side by side to make the choice crystal clear. This is where you figure out which tool is right for your job. When you lay it all out like this in a table, the choice really comes down to what you care about most. If scalability and central management are your top priorities, there's no contest. Transit Gateway wins hands down. But if your number one concern is keeping costs at rock bottom for a small, stable network, and you need the lowest latency possible, then VPC Peering is still a very strong option. It's that classic trade-off, simplicity at scale versus cost for smaller setups. Okay, enough with the theory. Let's get practical. Based on that comparison, when should you actually use one versus the other? Let's walk through some real-world scenarios. Let's talk about VPC peering. You're going to want to stick with this if your world is, well, pretty small and simple. If you have fewer than, say, 10 VPCs, you aren't planning some massive expansion, and every penny counts, peering is a fantastic, cost-effective solution. Oh, and here's a key technical detail. VPC peering lets you reference a security group in one VPC from a rule in another. This is super useful for fine-grained firewall rules, and that's a neat little trick that Transit Gateway actually can't do. Now, for Transit Gateway, you should be reaching for this tool the second scale becomes part of the conversation. If you have dozens of VPCs, or you even think you might one day, it's really the only sane choice. It's also the clear winner for any kind of hybrid cloud setup. And if you want one central place to manage, monitor, and maybe segment your network traffic, like keeping your dev environment totally separate from production, well, Transit Gateway was built for exactly that. You know, this quote from a cloud engineer really just nails it. It all comes down to a simple rule of thumb. That number, 10, is a really solid line in the sand. If you're managing less than 10 VPCs, the cost savings from peering are tough to ignore. But once you cross that line, you should seriously start planning a move to Transit Gateway to save yourself a world of pain later. So let's just leave you with this final thought. This choice between VPC peering and Transit Gateway, it's more than just a technical decision about routing. It's really a strategic decision about the future of your architecture. So you have to ask yourself, are you building a network that just solves today's problems, or are you actually engineering a foundation that's ready for whatever tomorrow throws at you? The answer to that question will tell you everything you need to know.